Hello, everyone, and welcome to another episode of Kelly Telly. Today, we're going to be looking at and kind of expanding upon our understanding of the term mass, which we looked at in the last video, and also introducing this concept of volume. Now, we're going to be looking at each of them kind of separately in this video. We're going to look at definitions for each, and we will touch on how they kind of are linked together. But we're going to go into a little bit more detail in later videos. But let's get started. All right, so mass. What is mass? So mass refers to the amount of matter that an object has. So the physical quantity of matter that an object has is what we refer to as mass, and it's measured in this unit kilograms, which of course you would have heard of before. Now, kilograms have the symbol, the letters kg to represent themselves, and kilograms is actually an SI unit, which you may have heard me say before. SI unit stands for System International, and it's a collection of units that are used by scientists all around the world to kind of convert whatever their measurement that they've got in whatever unit that their country uses, to convert it back into this SI unit so that they can compare data all across the world. But yeah, just jumping back to the definition of mass, it refers to the amount of matter that an object has. So why do I have a picture of an astronaut? Well, the reason is because this astronaut has a set amount of mass as he is currently floating in space, and he has that exact same mass when he is down on Earth. But that's a little bit different to this other term you've heard of before, which is weight. Okay, so let's have a bit of a look here. What I've written is mass is a set physical quantity, and it doesn't change due to external forces. Weight, on the other hand, is your mass, but it's adjusted to the current gravity. So, as I said, this astronaut here has a set mass. His mass would be the same in space, and his mass would be the same on Earth. But his weight would be much different on Earth than he currently has his weight in space. Okay, and just kind of like expanding upon this idea, we can look at the different planets. And if you were obviously somehow able to survive on the very different planets that we have in our solar system, um, you would actually have a different weight on each. Like for example, if you looked at Earth's moon, if you were if you were on Earth and you weighed 80 kilograms, and you stood on Earth's moon, you would actually weigh only 10 kilograms. If you were to go on Jupiter, for example, you would weigh 202 kilograms. So your weight changes. However, your mass is still going to be 80 kilograms no matter what on all those. So, moving on to the next topic, which is volume. So, what is volume? Volume is the amount of space that an object takes up. Now, this can be a little bit hard to kind of think about conceptually, but I want you to think about the amount of space that an object takes up compared to kind of it's even comparing it to its mass. So, volume is measured in the SI unit meters cubed. And we can kind of like look at the volume of different objects and compare how much space they take up. For example, your bed has a lot more volume than your computer monitor. Um, but it could have very different masses. One thing could weigh more than the other on Earth. So when we're looking at volume, we just want to refer to the amount of space that an object takes up. So if we think very basically, obviously this is not a three-dimensional object, but if we think about the game Tetris, um, if we think that each of the squares, the 2D squares in Tetris, is three-dimensional, 1 centimeter by 1 centimeter by 1 centimeter, so a centimeter cubed. Um, each of those different colored shapes, if you look at it, they actually all have the same volume. They all have they all take up 4 squares worth of space, if that makes sense. So in a game of Tetris, all of the falling pieces all have the same volume. This doesn't really make as much sense when we're talking about essentially when we're talking about like something like Tetris. But if we expand it to kind of like a real life example, something like a soccer ball and a bowling ball. If we were to have a bowling ball and a soccer ball that were the exact same size, um, we actually would have different. They would have the exact same volume, therefore. So if this soccer ball and this bowling ball have the exact same volume, which one of them is going to be to have more mass? We actually know this just from experience in our life. And we have a kind of an understanding to what would happen if, or sorry, not what would happen, but what if an object has a same volume but a different mass. We say that that object is more dense. So in this example, the bowling ball is more dense than the soccer ball, even though they have the same volume. So I'm going to say that one more time. We have a soccer ball and a bowling ball, and they both have the exact same volume. They both take up the same amount of space. However, when you look at their masses, the mass of a bowling ball is going to be a lot heavier than the mass of a soccer ball. When we have an object that has the same volume as another object, but that object weighs more, it has more mass, we say that that object is more dense. I hope that kind of helped to clarify the difference between mass and the difference between volume. I wanted to mention earlier when I put up the video of the slide of the different weight on different planets that it is going to be included in the description of the video. But apart from that, thanks for watching. I'll see you guys in the next episode.